Yes, welcome everybody to this webinar on the MIDRC mRALE Mastermind Challenge. I will start with bringing up my slides. I'm Karen Drucker from the University of Chicago, and I'm joined today by Ben Beers from the University of Colorado. So how this will work is I will give a short introduction, just a few slides, and then Ben will take it away with a live demo. Now, throughout the webinar, please use the Q&A feature, or you can also use the chat feature if you prefer to put your questions in. So don't save everything up till the end, but at the end is where we're going to answer questions. And Ben and I are the people who are mostly monitoring the forum of the challenge website. So we're the people you'll be dealing with if you have any questions, most likely. Okay. So most of you will, or all of you should have probably seen this flyer, but I just want to point out again, like our awesome prize money that we have now. And also what you perhaps did not know is that the winner and runner-up teams will have the opportunity to receive MIDRC support to get their code or models through the FDA regulatory process. So this is where our MIDRC sequestered commons comes into play. So there is a 20% of all the data that's ingested goes into this sequestered commons for algorithm testing by us. And this is where MIDRC would help you get your model through regulatory. Of course, your performance would have to be worthwhile in order to do that. In order to win any prize money, the only constraint is that you do have to outperform random guessing. Okay, so here are some websites of the challenge. Of course, you can reach everything through our midrc.org website, and then data.midrc.org is where our common data commons resides, and we also have a GitHub where you can find our challenge training set annotations, as well as a file manifest for downloading the data from the public-facing site if you choose to use our training cohort provided by MIDRC. You can also use your own data, but this must be disclosed when you submit in the test phase. And then the bottom address is our challenge platform itself. So what is mRALE? mRALE stands for Modified Radiology Assessment of Lung Edema. And this was a score developed for acute respiratory distress. And it's modified in that for the original score, each lung was divided in quadrants. And here, like you can see here, this is a snapshot of the interface for the annotators. Each lung is assessed as a whole. So extent of involvement of the right lung and density of opacity of the right lung, and the same for the left lung. And then the score is calculated using, numbers are assigned to different categories, and then the score is calculated as a multiplication and summation. Now you'll see that if you download the training cohort annotations, that these are also provided for the training set, just in case it's useful for your training. But however, the mRALE score itself is the only output that your model should return, which is an integer score between 0 and 24. So a little bit more about the training data that MIDRC provides. So there are about a little over 2,000 exams. These have been singly annotated. So single annotator, but they were from a pool of 20 plus expert chest radiologists who participated in our annotation events and who are acknowledged on our website. And the validation and test sets, they're triple annotated. And then we use the consensus as a reference standard. Those will be used in the validation and test phases. And the validation and test set distributions in terms of COVID severity and demographics are matched to the extent possible. So you will have, if you participate in the validation phase, there are about 200 cases in the validation phase. It's reasonable to expect that your performance will be similar for the test set, for which there is no leaderboard in the test set. And but there is for the validation set, so you'll know how you perform for the validation set, and that is to encourage some friendly competition. Okay, and here's the platform interface. You'll see much more of this when Ben goes through it. I just wanted to point out that there are tabs and each tab has different links. So it may take a little bit to get, to get used to it. The navigation might be a little getting used to. And then another important point is please register before it's too late. Our registration closes this Saturday. And maybe if you're an attendee of this webinar, we'll be able to work with you if you're register after that, but it would be really good idea to register now so you can participate in our practice phase, which will stop this Saturday. So now I'm going to hand it over to Ben, who will walk you through his live demo.
Hello, my name is Benjamin Burse. I'm from the University of Colorado, and I'm going to walk you all through the platform in general to give you a quick overview. So as soon as you've signed up and validated your email link, you'll be able to sign in and you can see your profile up here at the top.
Ben, did you mean to be sharing your screen?
I did. Thank you for
No problem.
letting me know that I am not. So I'll just rewind really quickly. So after you've signed in and used your email to validate your account, you'll be able to sign in and find the main challenge page, as Karen was showing in her slides. There's the details area at the first tab, and there's more data in general. A lot of this is going over what Karen just went over, but you can read it for yourself here. And we have tutorial links. And right now we're going to step through these videos essentially. So the phases tab just gives you an overview of the timing of the different phases. The participate tab is actually where you do most of the Docker image uploading and submission. So, this tab, the get data tab, gives you an idea of where the data comes from and the cohorts. This files tab is where you can download the starting kit. So I'm going to go ahead and start that now because it takes a minute. And then the submit view results tab has 3 different sections by phase. And so right now we're in training phase. And this Saturday is the validation phase. So make sure you're registered. And from there, you can upload an archive that will become your Docker image on the platform, and you'll be able to see them here. And when you're ready for a submission, you'll go ahead and click this blue button and find the image that you've already uploaded that you want to submit and go ahead and submit it. But first we need to build that. So we're going to step through that in a minute. So now that we have the starting kit, let's go ahead and get all of that going. So just find a place where you want to work with it and then extract it. So I'm going to go ahead and just move it to my desktop here, and you can use whatever editor you want. Of course, I'm going to use VS Code, and so here we have this starting kit. So I'm going to open up the README, and the first step is to unzip the archive, but we've already done that, so we can skip that. And then we need to go ahead and get into this starting kit working directory. So now we're there. So I have 2 sample submissions here in zip archive format, and we're going to work with one of those right now. So I'm going to unzip the PyTorch one. And what that will do is just make a folder for that archive here with all of the contents. And let's go through just a little bit of what's going on in this submission. So we have a Docker file that starts from the generic PyTorch Docker image, sets a working directory to app within the running container, copies in the requirements, which are simple here, but you can put whatever you want. Oh, I lost it. I'm just installing Vim for convenience. This is actually not necessary. Then we install the requirements. And then here I'm just copying in the inference code and the model. And these are just samples. And then baking into the Docker image a default command, which is just to run this inference file. So what we can do is first we need a Docker name. So I'm just going to go ahead and make a variable for that Docker name. I need to be inside this folder to build. And this is important because this is how the platform is going to build your image. So it's going to do exactly what I'm doing. It's going to grab this archive that you upload, excuse me, unzip it into a folder, CD into that folder and treat it as root and build from the Docker file in that directory. So anything in your Docker file that's referenced needs to be with reference to this root folder. So now that we're inside that directory, we can go ahead and build. So I've already built this, so it went really fast, but now we have this Docker image. So next, the data. So I provided some data, this practice data zip archive here. You need to go ahead and unzip this too. So I'm going to do that now. Oh, I forgot this step to just change directories back up one so that I can unzip the data correctly. Excuse me. So I've unzipped the data and you can see it here. So here are the DICOMs. So now that you've unzipped it and we can see this example of it here, we're ready to go ahead and begin making a sample, practice, I guess, inference run locally to just make sure everything's working. So we need to copy this practice data into this participant submission directory. What this is this is simulating a run on the platform. So basically you have an input and an output. The input is your images and the output is where you should put your mRALE scores. So to practice that, we just have like a bunch of blank directories here. And first for input, we need to copy the DICOM images into that input area. So we're going to do that first and refresh. And now we see in input a bunch of DICOMs. So now all I'm going to do is run the image we just built. I'm going to go ahead and put this input directory and map it or volume mount it to the input directory in the container and go ahead and place this output folder in and map it to the mount output directory inside the container as well. And when I run this, let's give it a minute. So what it should have done is copied out your model, which we want, and also copy out the mRALE score results by DICOM with this header. So this is the expected output. So basically that's what's going to happen behind the scenes when you make a submission over here. And so this is a way for you to just kind of practice that workflow. Finally, you'll notice I printed CUDA available false because right now we're in the training phase, which is a practice phase, and we're just using CPUs. So if we look just kind of closely at this inference file, which was run, if it found the GPU, it would have, printed something different, like a CUDA, that it found that, and but it didn't. It found the CPU. So that's, you can go ahead and like write your own code, but like this is just showing that we're not using the GPU right now, and it should print true otherwise. So now that everything seems to be working as we expect, we got the right output, everything's fine. We need to archive this whole folder into a zip archive that we can upload. So even though we already have one, I just kind of want to walk through that real quick because there are some errors that can happen. So this README is just talking about the output, but we've done that. So for PyTorch, I'm going to zip up everything into a new archive. So you can see that it's the same one as this original PyTorch archive, but it's just got the word new on it, essentially. But the important parts is that everything is at the root level directory. Sometimes when you use a UI or a GUI to archive things in like Mac or Windows, it will create a folder inside the archive that's the same name as the archive, and then all of your stuff is in there, and that's going to cause a failed submission because the root directory is not actually where the Docker file is. You need to go one level deeper. So try to zip up your files in such a way where the Docker file especially and everything relative to it are at the exact root level in the archive. So now that we have this, we need to upload it. So we go over to the training platform, and here under the submit view results area, there's an upload Docker archive. This is what we want to do. So we're going to go over to our starting kit where we made this new image archive and upload it. So it has to do a couple steps. It has to first obviously grab the archive. Then it needs to unzip it. It needs to build the image. It's going to push it to a private container registry that simulates, or I mean, it doesn't simulate it. It is basically like a Docker hub. It's just private. It's ours. And then once that's done, it'll be available in your uploaded images area and for submission. So just cleaning up. And so now we've uploaded an image. So we hit OK. And so now if we were to go to make a submission, we can see that we have this new option for this MIDRC Docker image inference PyTorch new that we had already built. And so you can go ahead and select it and submit it. And the platform will refresh the page as it kicks off a job. And we can see down here that your job is running. And, you know, depending on your code, it could take longer or shorter, but the template should be relatively quick. So now that you see that it's finished, everything went well. So what you have access to in the training phase is the output that you created, but not any scoring that is run on your output. So I apologize, but sometimes my internet here has been funny, and let's see if I can just get it again. But you shouldn't normally have this issue. But luckily, I already downloaded this beforehand just in case. So Docker outputs. So your output will come through with something like this. And here we can see the model that we had originally outputted and the score results. So where did those go? So the score results here are those integers between 0 and 24 that Karen mentioned earlier. We have the header file name path and score, and for each DICOM, a score. So that's what you should be able to download in general from the platform. And that pretty much wraps up the general use case of making a submission in general. The last thing I just want to touch on is Karen can remind me if I'm wrong, but I can see these results because I'm the challenge organizer, but you should not be able to. And I think there will be a phase at some point where we can see results. Karen, double check me on that. But it's definitely not training. And the forum. Please use this forum over here all the way on the right for any questions you may have. People are already kind of using it. We had some problems yesterday, but we'll be monitoring it very closely this week as you practice and in the following weeks when the GPU is online. So with that, the summary is essentially completed, and I think we want to turn it over to questions if we have any.
We do. Karen, do you see the box, and do you want to go ahead and take it away?
Yes, I see the box, but the questions are technical, so they're for Ben. He's much better at answering those than I am. But yeah, so the first two questions are actually one question. So that's about the version of PyTorch.
You don't need to use this exact PyTorch. You can use whatever you want. This was an example to just show you something that would work. But hopefully the whole point of using Docker submissions is that you can use anything in the world, ideally, that's on Docker Hub or whatever, and build your own base image. So no, this is not necessary. So then, yeah, this is totally fine. Probably preferred, actually, because it's not latest, it's a tag, and that's more reproducible. I would actually highly recommend not using anything with a latest tag, because if you try to reproduce these results in a couple months, that's actually a different Docker image. So I would highly recommend using something that actually looks just like this. This is actually preferred. So do we need to copy the model to the out directory? It already works with out. I think that's in a way a question for Karen. We're trying to collect these models, correct? We also, in a sense, I mean, you're not wrong, we have the uploaded archives. We're storing those, and that should have the model baked in. So theoretically, we already do have it, but that's just going to be date stamped, and it would be nice by submission if we could have that. So if you don't mind,
Right.
copy it
I mean,
out.
for the validation, I guess it doesn't really matter that much, but in the test phase, yes.
So real quick, I see Stanley is asking the same question in my mind. So yeah, I think it's up to Karen, but I think, yeah, please copy it to the out directory. So then maybe that could just have any more insight on the website crashing upon upload that happened in the last few days. So the insight I have is, like, last night I was working with the Microsoft support engineers, and they had to move this whole platform to a different node in the South Central US region where it's hosted. And I was getting these intermittent crashes of the VM in general. And also yesterday, it just so happens I was having Outlook 365 errors with my email. So I kind of think it was Microsoft's fault. That being said, it's definitely been the platform's fault before. So we're going to just watch often and try to just make sure that there's no issue. But we have limits set on the upload size. I think we have it listed somewhere in here. So right now we've set the archive limit to 15 gigs. So that's the limit of your zip archive. Please keep it below that. If for whatever reason you are getting the error message saying that your archive was too big, or yours is like 18 gigs and it's necessary, I'm sure we can change this. We're just trying to make sure there's enough space on the disk for everyone to upload their images. We don't want to, anything that's like 25 gigs or 30 gigs is going to take quite a while to upload too. We want to make sure your browser doesn't crash. So trying to just make things smooth, but we could adjust this limit worst case if it becomes a problem. CXRs, can you provide examples of CXRs?
Okay, it's a question I can answer. Yeah, so the question is about the manual filtering of the chest X-rays for the training set. So for the validation and test set, we selected one image per exam, and most exams indeed only had one image, because these are all portable chest radiographs, basically taken at patient bedside. So if everything goes well, there'll be one image and perhaps a processed image. So post-processing image you will want to eliminate. And sometimes multiple images are taken because of poor patient positioning, for example, because the patient is like slumped over in bed. So there are several reasons why you would want to eliminate images. I mean, one strategy could be just to include everything to try to, make your model more robust in training. Another way would be for imaging exams with multiple images to go through them and, eliminate the ones that are of poor image quality for one reason or another, or are post-processing. That's how we did it for the validation and test sets. I hope that answered your question.
Okay, just being clear, Ben answered that question from Stanley. In case everybody else isn't seeing, we wanted to make sure that got answered live. Stanley says, I use TensorFlow to train my models. My solution is more than one trained model. The TensorFlow save models in a folder. Is it okay to copy the whole model folder in the submission folder and the out folder? Quick answer, yes. Anybody else before we wrap up today? Any other questions, folks? This recording will also be made available online, so I hope everyone found it helpful, and you can review. I'll email you out the link. You can review the recording in the coming days for any questions that may arise, or you can please put them in the forum on the challenge platform so we can all benefit from the answers. And Karen and Ben are monitoring that closely.
Correct. Yes.
Anything else, Karen, that you wanted to say to folks? Just keep an eye on the dates and the times, obviously.
Yeah, please do some practice submissions so we put the platform through its paces, especially now that Microsoft seems to have had some problems over the weekend. So yeah.
One more
And may the
question.
best-
Oh,
Okay,
sorry, one more question
more
from
questions.
one more Stanley. Before we give them, may the best man win, best person win. Can you answer that one live, Ben? Do you see it? Are you muted, Ben?
I'm not 100% sure I understand. In batch mode. So the output is really the thing that is going to be scored and that the platform cares about. So however your algorithm runs, we just want like one CSV file with outputs for all the images. So I don't know if I'm answering that correctly.
Stanley, was that helpful? Let us know if there's more you need. And you can also, I believe there's a contact email for questions on the website, right, Ben? Yes, you mean output a CSV file.
Yeah, so if there were
Correct.
100 images, we would expect 100 rows, image name for each row and score. And then, you know, please have the header there because I use that to go look up these values. So even if you're doing a bunch of like, you know, batches and stuff, just make sure the final output, maybe you're appending batch scores to a CSV file, but the CSV file should have no concept of batches.
Okay, thanks, Ben. Anyone else? Going once, going twice? All right, Karen, you want to wrap it up?
Type really fast. Okay. All right. Well, I'd like to thank everybody for coming and for participating. And yeah, hopefully looking forward to a successful end of the challenge. Okay. Is there any other question? Oh, many things. Okay. All right.
Thank
Thanks,
you all.
everybody.
See you at the starting line.